Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at the determinants of a square matrix, and this is going to be assisting us trying to find a general way or a format of representing this specific aspect of a determinant of a square matrix. Now, in our previous discussion, we defined a square matrix basically as one of the different types of matrices which we are going to come across. And in this case, we talked about the upper triangular and lower triangular types of matrices as zero factor and other different forms. Now, in a sense, we said that for us to have a square matrix, we are going to have an n by n type of a matrix. And in this case, I'm going to be concentrating on, of course, evaluation of a 2 by 2 or a 3 by 3 type of matrices, which are going to be assisting us come up with, of course, a general format for us in evaluating a subsequent set of square matrices which we are going to come across. Now, I'm going to consider this a specific, of course, a matrix of A, whereby we're going to have A be represented by the general elements of this 2 by 2 matrix given as such. So these are going to be defined by those specific range of elements for the columns and the rows given as such. And for us to, of course, have this specific aspect of determinants, we're going to be having it given on this specific case. So we're going to see that there is a specific case in point whereby these particular determinants are going to be defined on square matrices. So in a sense, we can have this specific matrix given in terms of the determinant or the determinant of this specific matrix given in this specific case given as a B, E, T, A. So this is going to be giving a notation for the determinant of a matrix, of course, of A. In some cases, we are going to have this one being given using those specific notation. So we can have the determinant of this specific matrix of A given in terms of the product of the first elements of the matrix given as such, and of course the product of that one with the subsequent element which is going to be forming elements of the main diagonal given as such. And we're going to find the difference of those specific products with the product of elements given by the diagonal from the top right to the bottom left given by A1, 2 and A2, 1 given as such. So in a sense, we're going to have the product of these two elements minus the product of those two specific elements, which are going to give us the aspect of this specific matrix. So we are going to see that this particular matrix that we're going to define is going to be a scalar quantity, which can be defined for this square matrix, which we have given using that specific example. So suppose we have a matrix which is going to be given as a A, given by the range of characters for 1, 2, 3, and 4. And if we are required to find the determinant of this specific matrix, then therefore this is going to be a product of 1 times 4 minus 2 times 3. So basically, which is 4 minus this specific, of course, amount for 6. And this is going to be giving us the value of negative 2, which we said is going to be forming a scalar quantity. Now, in some cases, we're going to be given some specific definition for a particular matrix and be required to evaluate the unknown values of those specific elements. And this still is going to be taking the same approach for us in trying to evaluate the same case for different elements of a matrix. Now I'm going to use an evaluation example which is going to be assisting us to try to find that specific matrix. So if we have a matrix defined by these particular elements of y3, and then we have y minus 2. So if the matrix of this specific, of course, element for a 2 by 2 matrix is equivalent to 0, then we can find this specific element of known y and try to see all of this, basically lambda. So we're going to find the, of course, a known element of lambda. So we're going to find this by using the same procedure which we have just done for matrices, whereby we're going to have the main diagonal elements multiplied given using that specific evaluation, and then we're going to have this is going to be 3 lambda in a sense by having this a different type of a diagonal multiplied using that specific procedure. So this is going to be giving us the square of y minus 2. So this is basically lambda, the square of lambda minus 2 lambda minus 3 lambda given as such. And this is going to be giving us a 0 given as such. So this implies that the square of lambda minus 5 lambda is equivalent to 0. So we can have this one by perhaps having a division of this lambda on both sides of this equation. And this is going to be giving us lambda minus 5 is equivalent to 0, implying that lambda is equivalent to 5. So in a sense, this is going to be having a 5, and then a 3 in this specific sense. And that's going to be giving us various characters of this specific matrix. So suppose we consider a case whereby we're going to have a matrix whose determinant is 0, just as we have shown above. So this is going to be referred to as a singular matrix. So this is a matrix whose determinant is 0, just like the case which we have just, of course, evaluated on the board. And if the determinant of a matrix which is given as A is equivalent to 1, this is referred to as what we refer to as a unimodular kind of a matrix, a unimodular type of a matrix. And this is going to be assisting us try to define a different set of a matrix. So in case we come across a singular matrix for 0, unimodular for 1, that's going to be implying at the same. So we are going to look for the general way of representing the matrix of 3 by 3, just as we have been evaluating for 2 by 2. And we're going to consider a general case which we are going to be using for different characters of or elements of A. So we are going to have a matrix. Our matrix is represented in terms of a 3 by 3 matrix given as such. So we shall have those specific characters which are given as such. So it's going to be 1, 1, 2, 2, 3, 3. And then we shall have 3, 1, 3, 2, 2, 1, 2, 2, 2, 3, 1, 2, 1, 3 given as such. So these are going to be different elements of a matrix given in terms of this specific representation. So for this one, we're going to have the determinant of this matrix over A given in terms of this particular evaluation. So this is going to be implying that the determinant of A is equivalent to, so we're going to take these specific elements for the first, of course, row. So from our procedure for deleting the first row and the first column, we're going to see that if I perform this specific operation, I'm going to have this specific junction element of 1, 1. So this is going to be multiplied by the subsequent remaining elements of this specific case by finding the modulus or the matrix, the determinants of these remaining elements given as such. So I'm going to take this set of elements which are going to be a 2 by 2 submatrix given in terms of 3, 2, and then A 3, 3 given as such. So the product between this first element of this specific matrix and of course, the determinant of the subsequent or the remaining elements is going to be giving me the first set of a number for this specific product. And I'm going to find that one with the difference of, so I'm going to, of course, perform the same operation for the second element of the first row, and of course, the first, the first element of the second column and the first row given as such. So that's going to be giving me, of course, this specific, of course, evaluation, whereby this specific junction of A1, A2 is going to be forming a coefficient and then a negative coefficient, and then I'm going to have the remaining elements of A21, A23, A31, and A33 forming my, of course, a determinant over this submatrix, which is going to be remaining after this cancellation. And then I'm going to have that one as a sum of, so I'm going to perform the same procedure for the third case, whereby I'm going to have A13 and then the determinant of A21. So I'm going to have A22, A31, A32 given as such. And then I'm going to be having the determinant being given by this specific product. So that's going to imply that we are going to have this specific product and the determinant of this given using the difference between the product of this one and this one, just as we had performed from our previous examples. And this is going to be assisting me trying to find the matrices of such a kind of a 3 by 3 set which we are going to come across. So I'm going to use a specific example which is going to assist us in trying to, of course, understand this specific concept that is going to assist us evaluate such a kind of matrices for 3 by 3. So we will have to take this particular example whereby we're going to have our represented by, or the determinant of a matrix that's going to be represented by this specific, of course, a set of numbers. So we're going to have this one represented as 5, -2, and then we're going to have -3, say 4, 0, 1, and then we're going to have 3, -1, and 2. So if we are required to find the determinant of A, so we're going to use the same procedure and see that if we cancel the first column and the first, of course, row, that's going to give us this specific combination for the first element, which is going to be at the cross point of those specific matrix. And then the remaining submatrix of 0, 1, -1, 2 are going to be forming our product for that specific determinant. And then we're going to have the second, of course, element. So remember from our specific evaluation, we had the first element and then minus the second element such. For the first row, first column, first row, second column, we had this specific sign. But in this case, we're going to have a -2 and then negative, of course, this specific sign. Then therefore, the subsequent one for A, 1, 3 was addition. So it goes in that order that it's minus, plus for this case. So in this case, since the main element of this specific character is a minus, then therefore it's going to be plus at this specific product for the submatrix of 4, 1, and 3, 2, which is going to be remaining after cancellation of the first and the second. Of course, this is going to be 4, 3, 1, 2 given as such. And then we're going to have a plus the last one. So in this case, we're going to see that for this specific element, it's going to consist of a -3. Therefore, this specific sign is going to be compromised, and we're going to have a -3 at this specific point given in this particular order. So we shall have a 4, 0, and then we're going to have a 3, -1 given as such. So this is going to be giving us a product of a 5 times 11, which is going to be given in terms of sorry for that. So basically this is going to be 1. So this is going to be 0 minus, so this is going to be 0, the product of the main diagonal, minus the product of this, of course, a diagonal from the top right to the bottom left. So this is going to be 1. So subsequently we shall have those ones given in terms of 2, 5, and then for the last set we shall have of course -3 into -4. So this is going to be giving me a sum of 27, which is going to be, of course, the determinant of this specific matrix of 3 by 3 given as such. So we are going to be treating, of course, the second set of, or I say the subsequent set of square matrices using this specific procedure, and it's going to be assisting us trying to evaluate various sets of matrices which we are going to come across of this specific nature. So that is it for now, guys. Bye, God bless you. Catch us in our next video.